Hello viewers, hope you are doing well. Role of metallurgy in manufacturing industries. This video was presented in one of the seminar organized by Institution of Engineers. Okay, so I thought why not to share this video with all of you. So let's see what I presented in that particular seminar. And for your information, I can tell you that I was awarded a memento after the end of my lecture, and people appreciated also. So thinking that in mind, I am sharing this presentation with all of you, hoping that you would like it. And if you like, please like, comment, and if you are new to my channel, then please subscribe also. Okay. So what are various manufacturing industries where metallurgy plays a big role? I have suggested. So I have selected just few of them. Let's see. Metal-based industries. So forging, foundry, press shop, stampings, rolling mills, machining centers, heat treatment centers, and fasteners. So these are the various industries. Maybe somewhere it will be more, somewhere it will be less. But generally, these are the basic industries which are metal based and where metal is being used for manufacturing any product. Okay. So while running this type of business or this type of industry, what the owner or the GM of a plant or the plant head of a plant faces day-to-day problems or issues, that I will just give you a glimpse of that. First one is low production. These are the various issues faced by any organization, okay, in general. Low production, administrative and others like legal issues, union issues and all those things. Then high internal rejections, then parts failure at user's end, customer complaints, high production cost, quality issues, and poor customer base. So these are the various problems or issues in generally all metal-based industries, and these are being faced by most of the plant head owners or GM of a plant, okay, while running that particular plant. So out of this, I have selected few one where metallurgy plays a greater role because my title is Role of Metallurgy in Manufacturing Industry. So I have selected out of these few issues where metallurgy plays a big role. Okay, so let's see what are those. One is customer complaint, high production cost, quality problems, and part failure at user's end. You may ask that what is the difference between this customer complaint or complaint from customer and complaint from end user. So this I can differentiate. Suppose you are in a forging plant or in a foundry plant, or you are supplying your final product as forging to your immediate customer, like a four-wheeler unit or a tractor manufacturing unit or a two-wheeler unit where you supply your plant. So that becomes your immediate customer. But end user is that who is using your part, like farmer in case of tractor, or a passenger for a passenger car, or a motorcycle rider for a motorcycle. So all these things are end users. So this I have differentiated. Customer complaint is your immediate customer, and part failure is at user end is the one who is using your total assembly where your part is also assembled. So coming back to the point, customer complaint, high production cost, this is one of the reasons, quality problems, and then part failure. So these are the various areas out of those I have selected where a metallurgy plays a bigger role. So let's see how metallurgy plays a bigger role. So first of all, it was customer complaint. So customer complaints generally they are dimensional and metallurgical. Okay. So I am not going to touch upon the dimensional, but I will be touching only metallurgical because my topic is related to metallurgy only. So I will deal with this only. So what are the various customer complaints related to metallurgy? Let's see. Chemical composition, mechanical properties, microstructure, and breakage. Okay. In general, customer complains about any mix-up at their end, whatever you have supplied. There is a mix-up between E and 8 or maybe carbonizing grade of steel. Okay. So that could be a mix-up. So that is a general customer complaint which comes from the customer. Then mechanical properties like its hardness, its tensile strength, or it is impact properties if it is specified. So if there is something wrong with this, whatever you have supplied, then the customer complaint comes. Then microstructure, if your heat treatment is not proper, okay, if your hardening tempering is not proper, you are getting some mixed structure, or instead of hardened tempered, you are getting some normalized structure. Okay, so that type of problems in microstructure because of basically because of heat treatment problems. And the last one is your breakage. In case of breakage, wherever you are supplying your part, and if it goes to assembly shop and then it fails there, then that becomes a breakage at your immediate customer end. So these are the various issues which comes from your customer. So how metallurgy contributes? So customer complaint. What are the solutions? The first and foremost solution is your raw material sourcing from the prime source or prime producers. This is one of the basic reason. See, if you control your initial input, okay, then I can assure you that 75% of your product will be okay as far as final product quality is concerned. Of course, you have to maintain process parameters, but this is one of the prime reason where failures occur, where you cannot achieve the desired property after doing all heat treatment and everything, but you lack somewhere. Okay, and there is a customer complaint to you that this product is not having a good microstructure or a good hardness or anything. Okay, related to metallurgy. So this you have to maintain. You have to buy material from prime producers. Suppose I am taking case of a forging industry because I generally belong to forging as well as tractor industry. So I'll give example from forging and tractor based industries. So in that particular case, if you have taken a billets or bar from a trader or somewhere, there could be a chance of mix up because they don't keep their material with proper heat identified or even grade identified. So all those problems are there if you are buying from a trader. So you must buy from a prime source, prime steel producers. Okay, chances will be very less. Maybe 95% you may get everything okay. In 5% again we have to go for some initial checking. That's a different thing. But most of the cases you will be okay with this prime producers. Okay. Then the second is where you have to control is selecting a correct process, controlling and monitoring the process parameter. This is utmost requirement. Whatever forging or whatever things you are making, if you are going for a correct process, whether it is heat treatment, like normalizing, hardening, tempering, annealing, all those things, or even case carbonizing and other things, then you have to select a correct process which gives the final properties as desired by the customer. Then controlling that particular process parameters and monitoring also the process parameters. So these things are required while you are processing the material. Okay, after selecting the correct raw material, when you process it, these things have to be maintained. Then the third is that verifying the final product parameters before dispatch. Whatever quantity you are dispatching to your customer, immediate customer, you must verify before dispatch that whatever you are sending it is okay or not. For that, quality audit is being performed. Out of some lot, you take 5, 10 pieces or maybe 5%, 10% pieces, check for hardness, check for 1 or 2 pieces for micro and all those things, just to verify that your final product is okay or not. So if you maintain these things, I am sure that you will minimize your customer complaints. This is one of the solution where metallurgy plays a great role. Okay. Now I come to the second point. That point is high production cost. So how metallurgy helps in cost reduction? First of all, process modification. By modifying a process, you can also reduce the cost of the total overall cost. For example, there are cases where people are using carbonizing, but without compromising on the final property, they have shifted to induction hardening. And induction hardening, carbonizing, maybe pack carbonizing, any carbonizing generally takes 10 to 12 hours to maintain a particular depth. While in case of induction hardening, it takes few minutes only to get that particular case depth. And the production is very fast. Okay, within an hour you can produce thousands of components, where in this case the quantity is very limited and the process cycle is very high. So by using this, you can reduce the overall cost of your product. Okay. Then the other example could be forgings to PM parts. Now this PM parts means powder metallurgy parts, and it is also called sintered parts. Now these are going to be very popular nowadays, because in forging again, if you once you load the die, you produce hardly 3 to 4,000 components in a particular die run. Okay, depending upon the part shape and conditions. Okay, but in case of powder metallurgy, you produce the finished good, almost finished condition, and the quantity goes to around 50,000, 60,000, maybe in some cases. If the job is small, it can go up to lakhs in one die run. Okay. So that is the advantage of going for, but you have to confirm that the part parameters or part product qualities are matching with forging when whatever is required by the your end customers. Okay, that has to be confirmed. So here metallurgy plays a very vital role in selecting that what forges can be converted into PM parts. Okay, and this will definitely reduce your overall cost. Now go for the second aspect, that is material standardization. This also sometimes there are few materials which can be standardized, but people are not doing it, and for that they are suffering because small quantity has to be ordered. So in that particular case, some of the cases are like fasteners. In one of the tractor manufacturing industry, this particular project was taken, wherein all the fasteners were in, wherein all the fasteners information were collected, and they were trying to commonalize, whether in terms of material grade or in terms of your dimensional parameters. By adjusting 1 or 2 parameters, they could commonalize most of the fasteners, thereby reducing the procurement cost. Okay, so that also helps in reducing cost also. Similarly, for costings also, where the overall quantity requirement is very less, maybe you are producing a product, maybe um, 10 pieces or 100 pieces in 5 or 6 months. So quantity is very less, and for that you will need castings of different grades, very small quantity. So in that case, you can commonalize one casting. Maybe grade iron casting can be replaced with SG iron, though it will be slightly costly. But if you go as far as overall procurement cost, maybe it will be cheaper also. So it will reduce your, first of all, inventory problem also, keeping different grades at different places, wherein you can keep one grade at one place only. So overall, there will be a cost saving if you standardize a material. Okay. Then the third comes material substitution. If you substitute a material, that also will reduce your overall production cost. For example, from SAE 8620 to 20 MNCR5. This was done by most of the automotive industries earlier. They were using 8620, which is having nickel, moly, and chromium. Now they shifted to 20 MNCR, which is having only alloying element as chromium. So this becomes cheaper as compared to 8620, though the final product parameters or product quality remains the same. whether it is hardness, whether it is case depth and everything, that remains same. But the raw material cost from 8620 to this is quite less. Okay, so in that case, you also reduce the overall cost. So by substituting a material, you can reduce the cost also. Then comes quality. In quality, the overall quality, whatever you are supplying to your immediate customer, how it has to be maintained and where metallurgy contributes. Like in the beginning, I told you, incoming raw material control, this is very much required. Okay. Then in process control, and the last one is final product quality. If I go one by one, how you can maintain the quality, then let's go for incoming raw material. I'll talk about forging. So in case of forging, these are the various parameters which needs to be checked at the initial stage when you are receiving a raw material, whether it is chemistry or grade of the steel, internal soundness, inclusion rating, grain size, forgeability, geometry hardenability, step down test, dimensions and shape. So these things are required when you receive a material from a standard supplier. This is what I am telling, that if you buy this material from a reputed source, a standard source, these problems will be less as compared to buying a product or a raw material from a trader. Okay. So try to avoid this raw material from traders or any unknown sources, because you will face a lot of problem while processing that particular material and you will not maintain the quality required. Now the second is in process control. In process control, again I am going reference with this forging industry. Raw material cutting, here also you have to control uh, speed, feeding speed, raw material cutting speed. Okay, then you have to control the sizes also, sometimes different grades of material and they are of same size. Okay, so here also in during raw material cutting, you have to identify the material so that there is no mix up at the cutting stage. Okay, so this also control is required. In forging operation, again the forging heating temperature of the billets, then forging operation itself, how many strokes are to be made. Okay, that has to be checked. Okay, and with all particular dies and everything. Okay, die shapes, die cavities and everything has to be maintained in forging operation also. And when it comes to the final product after this forging, then we have to check the forging defects also, laps, dents and all those things, or cracks. So those things needs to be controlled during forging operation. So this process control during forging also. And again in heat treatment basically three things, that what temperature you are heating it, what heat treatment you are giving at what temperature, whatever the sorting time is there depending upon the part thickness. Okay, and then how you are pulling the object, whether it is normalizing, annealing, or even surface hardness treatment like carbonizing, reduction hardening. So all these parameters, process parameter, are required to be controlled during processing of that particular part. Okay, then I go for third, that is final product quality, means whatever has been done, how you control your final product quality. This is again example from forging only. You check few pieces of the lot which is being dispatched prior to that. Microstructure, one or two pieces you check as a sample. Then hardness you can check 5 to 10% for hardness because it's a non-destructive phase. Dimension also you can check 5 to 10%. Visual inspection for your surface defects. Okay, just whether cracks or other things are there or forging defects are there or not. Or MPI again for surface and subsurface case. Nowadays, this is being very common for all forgings which are being hardened and tempered. Okay, and even in finished product also MPI is being done for cracks. Then spectral testing is being done. Okay, and spark testing. So spectral for alloying elements, those are being checked. In that particular case, there are spectral pedestal type of spectral testing is there, where you check, take 5 or 10 pieces out of the lot which is need to be dispatched, and then check for a lying element, whether it is alloy steel or it is a plain carbon steel. By spark testing also you can check mix up of lot. If there is a low carbon with high carbon mix up, that also you can verify with spark test. So this is just before your final dispatch. So it's also called a quality audit type of thing, where you quality audit the lot before being dispatched. So if you maintain these things, okay, I'm sure your quality of your product will be definitely maintained, and you will have a less problem in your quality of the product. Okay. See, these are the some of the things nowadays coming very useful for metallurgical analysis, like spectral. It is for chemical analysis, very fast and accurate also. Image analyzer for all this inclusion rating, grain size, microstructure and all those things. Nowadays, image analyzers are there and people are using it because it gives a quantitative figure. In our days, when we were there, we used to check it and it's a qualitative analysis was there. But now, because of this recent developments and software, now you can quantify also, and there won't be any confusion between a sulfide or a silicate inclusion, which was earlier there. It was very difficult to recognize or identify a sulfide and a silicate inclusion in a steel. But nowadays, because of image analyzer, you can differentiate it and you can get the quantification also. Earlier, we used to compare with the standard chart. Okay, JK charts was there where we used to compare all these things. Now you come to ultrasonic. Now these things are also available. Ultrasonic, again, these are all NDT part, and nowadays so many instruments are coming, even hardness tester, ultrasonically based, I don't test, ultrasonically based. So nowadays this ultrasonics and ultrasonic based crack detectors as well as hardness testers, they have also come up. Okay, very useful portable type of hardness testers. And MPI, as I discussed you here only. Then SCADA, system for heat treatment. Portable hardness tester, again the same thing, ultrasonically based. And there are leaf hardness tester also. It's a impact testing type of hardness testers, which are also portable and non-destructive type. Then nowadays ultrasonic case depth measurement, these have also come up. You don't have to cut the piece and check the case depth. You can measure it, okay, without destructing the piece. So now these recent developments have come, okay, because of semi-automation or automation, okay. So these things are very helpful for all this metallurgical analysis, okay, whether it is raw material stage, process stage, or final product quality, they are very helpful, okay. So one should adopt these instruments also while doing that particular job, because this will ensure you the product quality also. Now coming back to the fourth point, that is part failure at end users or at user end. So where metallurgy can contribute. So let us see. First of all, what are the possible reasons of part failures at user end? It could be the design related. Maybe the design is not correct. Fillet radius, fitment errors, and all those things are there. So in that case, there could be a design error. Then metallurgy, again, all those metallurgical parameters like selection of material, then mechanical properties, microstructures, all these things may not be up to the requirement. Okay. Third is assembly fault. During assembly, there could be a misalignment of components, or there could be over tightening of studs and nuts and bolts. That could also cause a failure, okay, in field. And the last one is service abuse. For what particular purpose it has been made, it is not being used, it has been overused or overstressed. Okay, like you take the case of tractor, it's made for field application, okay, but people are using as a transport medium also, and with lot of overloading on the tractor itself, on their trolleys and other things. So that causes an overloading on the entire system, and it may result into a failure also, okay, during the service. So these are the possible reasons where this design metallurgy, assembly fault, or service abuse can lead to a part failure at the user end. Now, what a metallurgist can do? See, part failures at user's end. Steps in metallurgical failure analysis. Okay. So first of all, why this failure analysis is required? Why? The answer is failure. The answer is failures which occur in service when analyzed bring out the deficiencies in the system, be it in the manufacturing stage or selection of materials or design criteria or usage practice, etc. So adequate remedial measures are then taken to prevent or minimize the recurrence of such failures. In this process, failure analysis, here is the answer. In this process, failure analysis helps to improve product reliability by suggesting changes in the design, manufacturing process, materials, and also assists in extending the useful life of system or structure. So this is why this failure analysis is required, because it brings out the reason and it suggests whether there should be a change in the design or manufacturing process or material selection, or if they are not using as per their useful life also, maybe because of service abuse. So all these things are to be considered. Okay. So let's move further. Steps in metallurgical failure analysis. What are those steps? First of all, removal of failed parts from the assembly. This is a very important step in failure analysis, that whatever parts are to be removed within the assembly, they have to be removed very carefully. You should not hammer it out or press it out or even scratch it out. Otherwise, it will give a different indication on the failed parts. So it has to be taken out or removed very carefully when you are removing from assembly. Okay. Then receipt of the failed parts for investigation. So whatever parts has been failed, it has to go to the investigation laboratory where a metallurgist can analyze the failure. Okay. And not only the failed parts, apart from that, there could be some small parts also, some chips, something else related to failure that also has to be given to the laboratory for investigation. Okay. So failed part along with other parts which have failed in between, some chips or some smaller parts which have also failed. So a metallurgist can correlate why these failures have occurred. So everything has to be given to the laboratory for investigation. Then comes collection of background information. This is also required. Where the part has failed, what was the condition under which it has failed. Like suppose you take a case of tractor. In case of tractor, it goes to various areas, north, south, east, west, and the soil condition in different areas are different. Somewhere it is hard, somewhere it is soft. Okay, so those conditions are to be mentioned. Then climatic conditions also, whether it has failed in rainy season, winter season, summer season. So all these informations are required. These are the all background information which is to be given to the lab for investigation. Okay. Then a metallurgist, he analyzes the general service condition under what it has failed. Okay, whether it has been overused or there is service abuse, or even the background information like climate conditions, okay, soil conditions. So many things are there. Even in that case, suppose bearing is there, bearing has failed. So bearing, one has to see the condition of the bearings also, which has failed. Okay. Then the other thing is visual inspection. So the failed part has to be checked visually whether it is showing any crack or it is showing any burning mark or it is black mark or it is because of some uh, small failures. Okay, small cracks are there. Okay, like gears also there are sometimes small cracks which has developed on the teeth. So everything has to be looked very carefully, that what are the physically you are saying on the particular failed piece. Okay. Then what else? Visual examination continues. Then we go for non-destructive testing. That failed part which has failed, if it is to be examined for crack, surface crack or subsurface case, or by even ultrasonic testing for internal defects, it has to go for non-destructive examination. After that, fractography examination. See, in this case, I have shown two figures. This is one of the gear where this teeth has totally uprooted. Okay, complete teeth has gone. And this is one of the shaft which shows again failure from this part. This is the entire length. Okay, so failed part has failed. Now you can see in this that the failure has initiated with this surface itself. It's not very clear, but these are ratchet marks. This white shining areas, arrow type ratchet marks are there. And then the failure, the crack has propagated from here to here. See, this is a very smooth area. Okay. And then the final area is a very rough area. So it is a fractured area, final fracture is there. So it says it's a kind of fatigue failure because of this smooth and rough zone. Wherever you find smooth and rough zone, it is an indication of a fatigue failure. Maybe variety of fatigue failures are there, rotating fatigue, bending fatigue, okay, transverse, longitudinal, so many things are there. But the initial observation is if it is a plane and a rough surface, then it means it is a fatigue failure. So a metallurgist, he analyzes this fracture also. And in this case also, this if teeth is uprooted, it can be because of overloading also. The teeth has completely gone. Then one has to see the condition of these teeth also, nearby teeth, whether they have also developed some cracks or not. And these are to be examined microscopically also to know the nature of the crack propagation, okay, which has not failed. This has failed, but by these cases, if there are cracks are there, and then one has to see the crack from this area, also land area of the teeth, okay, or some scaling off at this area also. Sometimes those things happen in gear failure. So one has to see very carefully the fracture of the teeth, whatever has gone out, okay, and based on this, one can visualize that what could have gone wrong in the service, okay. Then after fractography, then metallurgical test. When you go all this testing, then go metallurgical test like chemical composition. You have to check material grade is okay or not. Then you have to see the mechanical properties like tensile strength, hardness, or even impact and all those values if it is possible. Okay, to take out from the sample, then you have to go for that. If it is not possible, then you have to leave whatever you can check. You have to check it, and then the microstructure. Okay, that also you have to see. Okay, so all these tests are required. Metallurgical tests are required, which can be done by some portable instruments also, modern instruments also, or destructive testing also. So all these tests are to be performed. Okay, chemical analysis, mechanical testing, and metallographic examination. These are to be carried out of the failed part which has failed. Then you go for analysis after collecting all those information, background information, service conditions, okay, and then fracture examination, everything, magnetic particle inspection, non-destructive testing. Then you analyze the entire scenario. Like a murder mystery, you see, same thing. All the evidences are collected and then they are to be analyzed and they are to be sequenced also. That what could have been sequence of the murder, okay? How it started and how it has propagated. Same thing here also. Whatever failure has occurred, how the crack has developed, how it has propagated, and how it has finally fractured. So all these things are to be analyzed, and then one has to reach a final conclusion. Okay, then what could be the possible reason, whether it is overstress in the service or service abuse is there, or there was some initial crack, or the raw material was not good, or the heat treatment was not good. Because of that, the microstructure was not good. So many things are there. So one has to conclude it that what could be the cause of the failure, so that after concluding that, then the recommendation is given, whether it is a recommendation for design improvement, or for material selection, or for process changes. So all those things are given in the report. And finally, the report is issued to the concerned department. Failure analysis report is issued not only to the concerned department, but also to the departments which are responsible. If there is a recommendation for design changes, then it has to go to design also. If there is a recommendation for metallurgical improvement, material selection, then it has to go. If there is a requirement for process improvement or process change, it has to go to the manufacturing area also. So all these things are given in the failure analysis report, and accordingly actions are taken so that in future your part which has failed, it should not fail in future also. And whatever part you are supplying or whatever the tractor you are supplying to your customer, okay, that runs perfectly okay, and there should not be any failure in between. So this is how this complete failure analysis is done in case of a failed part which has failed in service. Okay. Now, if I can summarize this, see, I am summarizing only those areas where metallurgy contribution is there. Like in part development, again, go for material selection, whether whatever material was selected for that particular part, whether it is okay or not, it is as per the design requirement or not, whatever strength is required, it is giving that particular strength or not, whether by way of heat treatment or by way of surface treatment like case carburizing, induction hardening. So those are to be seen by the metallurgist basically. Then in the manufacturing, what were the area? The manufacturing, first of all, raw material quality, then your heat treatment cycle, whether whatever heat treatment cycle has been given, was it okay as per the requirement? Okay, and it gives the final result, final properties, and then metallurgical testing. So these are the area in the manufacturing where a metallurgy contributes. Okay, now come to the next final product. So in final product again, metallurgy plays a good role because the part before dispatch it has to go for a quality audit. This I have explained earlier also. So, in a complete development of a part, okay, these are the various steps or development, manufacturing, and final product. And in all these areas where metallurgy is playing a very big role, okay, in material selection, raw material quality, heat treatment cycle, metallurgical testing, and quality audit. So all these are being contributed by the metallurgy department, okay. So this was my topic basically, wherein I have just dealt basically what are the areas, what are the role of a metallurgy in case of any manufacturing industry. See, I have taken example of a tractor, okay, and I have taken example of a forging industry. But if you see, these basic things are for every process, every industry, whether it is a uh, sheet metal based industries, okay, or it is a machine shop, or it is a casting foundry industry is there, CNC, whatever, even fasteners, heat treatment, in all these cases, you go for these three steps where this metallurgy contribution is highly expected, and metallurgy has to perform very well. Otherwise, there could be a failure. So, my request to all the industrialists, those who are involved in manufacturing of various components, because of so many manufacturing methods, they must consider the importance of metallurgy in selection of material, manufacturing, and as well as final production. So, how was the presentation? Of course, it was liked by most of the participants. Hope you would have also liked it. So, if you have liked it, then please like, give your suggestions or comments. And if you are new to my channel, please subscribe also. So, thank you. Thank you very much.